Chapter 21, Problem 22. The ion source in a mass spectrometer produces both singly and doubly ionized species, X plus and X2 plus. The difference in mass between these species is too small to be detected. Both species are accelerated through the same electric potential difference, and both experience the same magnetic field, which causes them to move on circular paths. The radius of the path for the species X plus is R1, while the radius for the species X2 plus is R2. Find the ratio R1 to R2 of the radii. So, in this problem, I guess you find the equation that relates to the radius of the circular path that they're talking about in the problem. And that is R equals to M times V over Q times B. So M is the mass of the species, V is the speed, Q is the magnitude of the charge, and B is the magnitude of the magnetic field. So, you kind of have to know something about the speed in order to use this equation. So, for an electric potential difference, V, and a charge Q, the electric potential energy lost would be this. Q times V. V representing the potential difference. And this here, make sure this is the velocity or the speed, and this is the potential difference. And then the kinetic energy, which they spoke about in the problem, is represented as half mv squared. So, let me take away what I just said about it being in the problem, but you kind of need to know the kinetic energy of the species because it's moving. So from there, you just set each to equal each other. Or you can write it like this. Just to set it equal to the speed. So it's the square root of 2q times v, which is the electric potential difference, over the mass. And that's equal to the speed or velocity of the species that's moving in the circular path, like I mentioned before. So now you use this equation right here. And you have the equation for V. So pretty much all you have to do is substitute for V. So R is equal to M over Q times B times 2Q times potential difference over M. And then what you want to do is you can kind of simplify it to this. Now, afterwards, we're just going to use, this is basically the equation that you're going to use to find the radius of the first species, which is X plus. Instead of Q, you're just going to put E. And we're just going to use E to represent the charge on the electron. So now they ask us to find the ratio of R1 to R2 of the radii. So you just use this, what I calculated above right here. Everything is pretty much going to stay the same up until you get to the charge. Because in the beginning they said the mass spectrometer produces both singly and doubly ionized species. So one of them, which will be R2, will be doubled. So, afterwards, pretty much everything is going to cancel out, except for, and then you're just going to be left with the square root of 2. And you just calculate that, you put that in your calculator, and the answer you'll get is 1.41. And that, I believe, is the ratio of R1 over R2 of the radius.